This will be a tutorial covering how to use the low-pass filtering capability on the analog-to-digital converter with Computation. This peripheral is featured on most newer PIC devices. By the end of this video, you should have a good understanding of how to set up the low-pass filtering capability. Additionally, you will be able to calculate the cutoff frequency of your low-pass filter based on parameters set in MCC. So if doing something like this interests you, please continue watching. I'm starting with my MPLAB-X project open and configured for the PIC 16F18855 and the code configurator opened. I'm going to print the results of the low-pass filter to the data visualizer. Therefore, I need to add a USART peripheral. I also need to enable transmit and set the TX pin to RC0 in the pin manager. I would like to use a timer to periodically trigger my ADCC every 1 millisecond. Therefore, I will first add a timer to peripheral. I will also change my clock source to low frequency internal oscillator. Additionally, I will change my timer period to 1 millisecond. Next, I will add an ADCC peripheral. I'll first change my operating mode to low pass filter mode. In order to periodically trigger the ADCC every 1 millisecond, I will set my auto conversion trigger to timer 2. Scrolling down to the computation feature, I will set the threshold interrupt to enabled. This means that the threshold interrupt will be triggered every time the ADCC has finished the set number of conversion repeats regardless of the threshold comparison results. Next, we will set up the low-pass filter parameters. App Note 2749 describes in great detail how to use the low-pass filter on a PIC 18F26K42. However, these same methods can be used within this project as well. A link to this app note will be provided in the description. The app note describes how to calculate the -3 dB cutoff point in terms of frequency by using this equation. The variable t is the total sampling time or measured time between samples according to this equation. Looking back at MCC, I can see that the acquisition time of an ADCC read is only 23 microseconds. However, there are instructions within the ADCC routine that also take time to execute. If you remember, the ADCC is set to be automatically triggered every 1 millisecond by our timer 2 peripheral. 1 millisecond should be more than enough time for the ADCC to complete its sampling. Therefore, I will use 1 millisecond for t. To complete this equation, I need to go to the PIC 16F18855 datasheet and navigate to table 23-4. The value of the right shift bit in MCC determines what the -3 dB point is in radians. I will choose a right shift value of 3 and then calculate the cutoff frequency. This now means that I have a cutoff point of 0.134 in radians. Once the cutoff frequency is calculated, I can verify whether or not the cutoff frequency works for my application. Now that I have determined all of the missing values, I can calculate that my cutoff frequency is about 21 Hz. A cutoff frequency of 21 Hz is acceptable for this example. Therefore, I will set the right shift value to 3 inside of MCC. The repeat value should always be 2 to the power of the right shift value. Therefore, I will set repeat to 8. Inside of the pin manager, I will need to choose an ADCC input pin. I will set this pin to RC7. Additionally, inside the pin module, I will need to give this pin a name. This is all of the setup that I need to do for the low-pass filter, so I will go ahead and click the Generate button. Inside of my main.c file, I will uncomment global and peripheral interrupts and also call the start conversion function outside of the while loop. Inside of the ADCC.c file, I will scroll down to the interrupt handler and get the filtered value. I will be using the data visualizer to plot the data of the filtered ADCC result. In order to visualize this data, the filtered value must be printed in a certain format. More information about how to use the data visualizer for graphing ADCC filtered values is explained in further detail in the linked app note. In the data visualizer, I have the output of the low-pass filter being printed to the graph. Using a signal generator, I am generating a square wave. As you can see, as the frequency of the square wave increases, the waveform changes as well. After a high enough frequency, the square wave begins to attenuate. Next, I will add periodic noise to a DC signal. When I begin to increase the frequency of the periodic noise, as we approach the calculated cutoff frequency, you can see the noise begin to reduce. In this video, we covered how to set up the low-pass filter in MCC. Additionally, we learned how to use the datasheet to calculate the cutoff frequency of the low-pass filter based on parameters set in MCC. For more information about the low-pass filter or the ADCC, please see the link provided in the description below.